That's really surprising, I must say. Okay, so please, Mohammed Reza Khosravani. Yes. Yeah, that's the problem. If you're chairing yourself, then it's I didn't get a cue.
Hello, everybody. Thank you very much.
Oh, sorry.
Hello, everybody. Thank you very much for your attention to this presentation. My name is Mohammed Reza Khosravani from University of Siegen. And in this presentation, I would like to present our intelligent implementation, which predict the mechanical failure and fracture in the composite joints. This presentation includes some introduction about the composite material and branches of AI, and then I will continue with the advantage of composite material, especially or particularly sandwich joints, and I will describe the concept of CBR and our implemented system, and finally I will conclude. I hope to finish in 15 minutes. Combination of two or more material to reach the better physical and mechanical properties, as you know, is called composite, and particularly sandwich composite, as you see in this picture, consists of some face sheets and one core, which is especially or most of the time is honeycomb as a core material. An important thing about the behavior and the application of the material under loading is that generally in mechanical engineering we have two types of the loading, which are static loading and dynamic loading. By definition, a static load exerts a constant amount of the force, but the dynamic loading is a varying amount of the force constant about the structure. In this slide, you can see also the loading range from the low strain rate till high strain rate. You can see that, for example, creep test, we have very low strain rate, and split Hopkinson bar or Taylor impact test, which are conducted under very high strain rate. As this implementation consists of some a branch of the AI, just in this slide I want to summarize or mention different branches of artificial intelligence, for example, Bayesian network, artificial neural network, or genetic algorithm, and particularly we use case-based reasoning as a branch of the AI. And all of this branch can be used for predict failure or mechanical properties of different structural elements, and they can reduce human dependency or increase the productivity. Last year, we published one review paper, which is application of artificial intelligence in fracture mechanics in this regards. We divided fracture mechanics to 4 different subdomains, and we review 5 different AI in this application. Here, we focus to the sandwich composites, which are usually used in the interior of the aircraft. For example, you can see in the ducting flooring or different part of the interior and the galley, they use sandwich composites. They are high resistance to the fatigue life and the corrosion. There are different unique or favorable properties. All of these parts consist of some different type of the joint. For example, you can see that I presented different joints. For example, T joint, P joints, or butt joint, insert joints, or corner joints in different. Sorry. Oh. You can see that all of these joints are used in preparation or manufacturing of the interior part of the passenger aircraft. To predict the failure in this part or structural element, we use case-based reasoning. Case-based reasoning is a branch of the AI, which consists of four important phases. All are started with R: retrieve, reuse, revise, and retain. Here, just shortly, I describe all the phases. For example, retrieve is a new case, should be mapped to the CBR based on the feature and the value. Or reuse is transformation of the previous similar solution for the new one, and the revise is checking the correctness of the new solution, and retain is a storing of the finding to the case base. For the CBR implementation, various parameters play an important role for the implementation of the artificial intelligence system. For example, particularly in the sandwich T-joint, type of the joint, core material, thickness, or jointlet, or adhesive type should be considered precisely, and all of these parameters, which we call features, should be defined in the case definition or creation, and regarding to the influence of these parts, we should define a weight. And for the making the case base, we use work of the 26 research which are documented already, and for the case similarity, we use this formula which depends to the weight of each parameter. And regarding to the achieved result, we define the weights. For example, the influence of the thickness of the core to the behavior of the material, or influence of the type of the adhesive to the behavior of the joints. For each case is determined. And this is the overview of the proposed system. That's how the CBR system should work. And in the last step, case is a case reuse, and finally the system can predict the failure load and the type of the failure also. You can see in this slide that when the similarity is more than 80%, it will be stored in our case base for the future application. Also, for the system, for evaluation of our system, we tested one series of the composite T-joints which are used in the aircraft galley, and you can see we conducted the tensile test in the static condition, and the detail of the specimen is presented here. For example, the type of the face sheet, or thickness of the core, or type of honeycomb and loading type. And output of this or system is predicting failure load and type of failure. I mean, parallel to this test, or without doing this test, this intelligent system can predict the failure load or type of failure of this joint. For example, it can predict which is the cohesive failure or mixed fail, or like that. This is the graphical user interface of our system. You can see, for example, joint type, core material, or core thickness can be defined by the user as an input. And finally, the similar case will be shown as an output, and failure load and type of failure will be predicted with high similarity. Just as a conclusion, I can say that in this short presentation, I described definition of the composite and application of the sandwich composite in the aircraft, and also concept of the CBR I presented, and also some important point in implementation of our intelligence system. This system can save the time and cost, and we evaluated this system by comparing the result with our mechanical system that we have done. And for the future work, we are going to implement a system to predict fracture in a big group of the composite joints. Thank you for your attention.
Okay, thank you. Very well on time.